Hello everyone. This is my full course of JavaScript. If you're new to web development, this is your career game changer. Stay tuned. Everyone. In this video, we are going to learn about overview of JavaScript functionality, and we'll deep dive into JavaScript engines and their components like call stack and heap, and we'll learn how it will works, and we'll learn compilation, interpretation, and JIT compilation. Then we'll deep dive into JIT compilation, and finally we'll recap this video. Let's quickly recap why JavaScript first. In early days, I mean before 90s, our web pages is like a static one. It just display the content in the fixed layout, like pages in the books. So people are getting bored because of no interaction, no animation like that. So for that issue, after 90s, the JavaScript was introduced. So we will see how the JavaScript works. So in 95s, the JavaScript runs inside the browser using the inbuilt JavaScript engine. So don't get confused what's the engine. Just imagine it's like a piece of code written inside the browser. We'll learn this more in little later. So inbuilt JavaScript engine having compiler. So it will compile our JavaScript code and it will convert our code into machine code like zeros and ones, and it will produce the output. So like this, JavaScript inside the browser working. For example, Chrome's V8 engine and Edge's Chakra, those are the latest JavaScript engines are working like this. So we understood by using JavaScript, we are doing many things in our web pages like carousels, on-click functionality, and pagination, sort, search, and many things we are doing using JavaScript. But there is a one limitation because we are having JavaScript engine inside the browser only. So the engine only compiles our code. So we can't use this JavaScript engine outside the browser. So we can't utilize the 100% of our JavaScript. So people are thinking for the improvements. So finally we got one idea in 2009. The Ryan Dale had an idea. He is a software engineer in America. What he did is he used the JavaScript engine from the browser and he wrapped it inside the C++ code, and finally he named it as a Node.js. By using this, you can see the JavaScript engine comes outside the browser. Got it? Here the browser, but here no browser. He wrapped it inside the C++ engine. So finally, it's called as a Node.js. So by using Node.js, we can use the JavaScript engine outside the browser. So you can just easily understand here. The C++ engine inside we are having Google V8 engine. It's called as a Node.js. So it's a very important milestone in our web browser web development. So using that Node.js, we can develop the web application and mobile application like in many video games and some games, and using backend application like APIs and many things we can do by using Node.js. So just remember, this is a very important milestone in web development. So we saw the overview of JavaScript engine. Now we'll go a bit deeply into JavaScript engine. So as I told, JavaScript engine is basically a computer program. It will execute our JavaScript code inside the browser. Okay, basically. So this is our JavaScript code. First step, it will execute our code. Then it will produce the output. Basically, this is the process. During the execution, the JavaScript engine having multiple steps for the execution. For example, parsing and convert to machine code. First, parsing means our code is converted into some structure that the language understandable format. Then that understandable format is converted into machine code like zeros and ones. So finally, the zeros and ones are read by our computer processor. Then it will produce the output. So we get some clarification about this because our every V8 engines are working like this. So next, the call stack. The call stack is a very important concept in the JavaScript engine. You can just think where our JavaScript code execute. So now the answer is our code will run inside the inside the call stack. So you can see our code execute inside the call stack using something is called execution context. Here I added some example code for your understanding. For example, let x equal to, I declared two variable x and y having a variable 10 and 5. Here I added the addition, then subtraction. Finally, I consoled that values. So how our JavaScript work is, it will execute line by line. For example, it will execute first line, then it will goes to second line. After the execution, it will goes to third line, then fourth line, then fifth line. So it will execute line by line. So it's called as a synchronous process. Okay. Then it will do one thing at a one time. So you can see it execute one at a time. So it is called as a single threaded. So now you understand JavaScript is a single thread synchronous program. So this is a very important interview question. If you not get cleared, just pause this video and we'll backward again we'll learn. Now the second important component of our JavaScript engine is called Heap. It's a storage. It will store the data that our application needs. So it isn't having any fixed size. The JavaScript engine will allocate the size according to our requirement. This heap will contains key value pairs and variables and functions. Here key value pairs means basically a JSON. You will learn this in little later. Just consider it's a one variable. Okay. So the second one is called variable. It's like a let and constant variable like this. Then it will store the function details like this. Here I added some example called sign up the user. So here it will validate the user for the initial login. So these are the details are stored in our JavaScript heap. Next, the engine does not have allocate the fixed amount of size. It will allocate the size based on the requirement. And finally, these are the storages are cleared. So we learned the important components of our JavaScript engine and how the code was executed. But we have one question, right? How our code is compiled to machine code, right? So for that we need to recall some computer terminology called compilation and interpretation. Those things are we learned in our school days, right? For example, our computer processor didn't understand our coding language. It will understand machine language only, right? That means zeros and ones. So ultimately our code need to convert into zeros and ones, right? For that compiler and interpreters are used. Basically our code enters into compiler. It will process our code and it will convert our code into some tree structure called AST. Then it will come, those structures are converted into zeros and ones. Those zeros and ones are processed by our computer processor. Then our computer processor will produce the output. Now we'll see compilation, interpretation and JIT compilation in one by one. Now the first one, compilation. In compilation, our source code is converted into machine code. Then that machine code is stored into one portable file. That portable file is called as a binary file. It will store into our system. Then that file is read by our processor. That processor will execute our output. So I will repeat again. Our source code is converted into machine code. Then that machine code is stored into one file. Then that file was executed by our processor. So it will produce output. Now this is compilation method. Now the second one, interpretation method. In this method, similar to compilation, but you can see it will contain only two steps. Initially, the source code is compiled and executed by the processor, so it will produce the output. These things are happen line by line. For example, in first line it will compile, it will convert to machine code, then that machine code executed. In second line it will compile to machine code, then that machine code is executed. In third line it will compile, then it will execute. So you can imagine, if we are having 1000 line of code or a big application, means each line it compile and execution means, just imagine very tedious process. So it will take very time to execute all our code. So it's very slow and low performance. We didn't like this, right? For example, if you are using Google Map, for each and every drag it will take 1 second, means just imagine, it's not acceptable, right? So for that purpose, JIT compilation was introduced. Basically, the JIT compilation is combination of compilation and interpretation. Okay, here I will explain. In this method, our source code is converted into machine code. Then that converted machine code is executed immediately. Got it? Here we are not storing to our system, so it will compile immediately. It will execute. Compile immediately execute. So our entire code is compiled at once. Then it will execute immediately. It's not going line by line. So in first step, it will do rough compilation, then it will execute immediately. So we can see the result. Then that rough compiled code is optimized in side by side simultaneously. We will see that more in JIT compilation brief session. So our JavaScript engines are working with using JIT compilation method. But many people I saw, they are telling JavaScript using interpretation method. If you know someone telling like this, means just forward this video so that they can learn. Now we'll deep dive into JIT compilation, because our JavaScript engine using JIT compilation. So just imagine this box is our JavaScript engine. Inside JavaScript engine, our code initially getting parsed. Parsed means engine reading our code. So while reading, our engine convert our code into some structure called abstract syntax tree. So in this structure, engine will convert our code into some structure. Those structure are understandable by the JavaScript engine. So here I added some example. For example, here I added a addition and a multiplication program. So it will convert, initially it will do addition, then it will do multiplication. I will explain clearly one by one what it will do. Okay, it will split each line of code into small pieces. Those pieces are understandable by the compiler, I mean JavaScript engine. Then those pieces of code are finally combined and it will form a one full structure. Okay, those full structure are converted into machine code finally. Okay, and that means zeros and ones. This step also check the syntax error. If we missed some syntax, or if we wrongly declare something, means it will throw the error called syntax error. These error are happen in this steps, find out in this step. Now we'll see the example for AST. Here I declared one variable, let x equal to 10. This is my sample code. You can see the AST structure here. Here AST structure is one JSON. It's contain type program and body is an again array of objects. So inside object you are having multiple properties. Here type equal to variable declaration, and kind means let, it means this one where type, and declaration having multiple things again, variable declarator and id type identifier, and a variable name is x. You can see it's this value is int, so it will contain int property, int with type literal and value 10 and raw 10. This is given for just for understanding purpose. Just imagine if the code contain more than 1000 or 2000 line, or big application, means how our code is converted into AST, then AST is converted into machine code, then that machine code will compiled by the compiler. So just imagine, say, how big process. But converting this AST structure and machine code as not a mandatory one. For our broad view, I am giving this example. Just understand this, not a mandatory one. Now you learned how our code is getting parsed and converted into AST, right? After that, our AST is converted into machine code like zeros and ones. Then that zeros and ones are executed by our computer processor. So it will produce the output. So these are the things that happen inside the JavaScript call stack. If you think this is final, this is not a final one, because our modern JavaScript engines are having optimization strategies for improving the performance. For example, here you can see in modern JavaScript engine, our parsed code is roughly compiled roughly converted into machine code, then it will do execution immediately. It will do execution. So rough compiled code will execute, so we can see the output very fast. In the background, the unoptimized code is converted into optimized code. They are having some strategies called optimization process. So our unoptimized code will simultaneously in background, it will convert, it will optimize the code, then optimize it to machine code, then optimized machine code will execution. You can understand, right? See, you can see the here initially the unoptimized code very fastly you can see, then background is optimized, then optimized code will recompile, then it will execute. So finally every optimization, that unoptimized code is getting cleared. So finally we can get optimized code, right? This is for optimizing the performance. So you can see each optimization after cleared. So modern JavaScript engines are very fast. Here you can see some key points takeaway from this. Compilation, execution, optimization, this will happen in special thread. So these processes are happen in some special thread inside JavaScript engine. We can't access this by using our code. But this is a overview of JIT compilation. Mostly different engines are using this in some different way according to their need. But this is the overview. You can see V8 or Edge or SpiderMonkey using this way, but slightly some changes may occur. Now quickly summarize this video. So the JavaScript engine is a program that runs inside the browser only, because browser having JavaScript engine. After that, the engines are came outside the browser. It's called as a Node.js, because JavaScript engine is wrapped inside the C++ program. So it is called as a Node.js. So by using Node.js, we can use JavaScript engine outside the browser. For example, mobile application, web application, something like that. Okay. So the JavaScript engine having two major components. One is called call stack. Inside the call stack, our code will be executed. The second one is called heap. Heap is just like a memory pool. It's not having any fixed size. Our JavaScript engine will allocate the size according to the requirement. So that compilation. In compilation method, our source code is converted into machine code at a time. Then that machine code is stored into one file in our computer system. Then that file was executed by the computer processor. Okay. After that, interpretation. In interpretation method, our source code is converted into machine code and execute line by line. For example, first line convert to machine code, then it will execute. Second line convert to machine code, then it will execute. Third line machine code execution. So it will happen line by line. It's taking time, so it's a very low performance one. So we are not using this. After that, JIT compilation. In JIT compilation, our code is converted into machine code at a once, then it will execute it immediately. Got it? Every code is converted into machine code at a once, then it will execute immediately. It will not execute line by line. So JIT compilation is a combination of compilation and interpretation. If you not clear means just watch this session again. But I saw most of the people are saying JavaScript is interpretation method, using interpretation method. But if you notice someone who is saying this means, just forward this video so that they can learn. Okay. Now the modern JavaScript engine using JIT compilation, right? But it having some optimization methods, so it will produce output very quickly. For example, initially it will convert a rough machine code, it will execute. In the background, it will convert that rough optimized code into optimized code by using some optimization strategy. So finally the unoptimized code is getting optimized, then that code or unoptimized code is getting cleared simultaneously. Okay. Next video we'll see JavaScript runtime. Okay. If you have some feedback or suggestions means, just post it to the comments below so that I will learn. If you like my work, feel free to like, share and subscribe my channel. Thank you.